after a long time I'm going to upload this video. So in last classes we discussed about complex numbers, that what are the complex numbers and how the imaginary number and real numbers form the state of complex numbers. So now it's time to discuss more thing about the topics related to complex numbers. Okay, so the topic is cube roots of unity. So we know that what is unity. So unity means 1. So you have already known to it that the cube root of unity, which we are known to it, is 1. Okay, so the cube root of 1 is 1. Okay, we know that. But are there any other cube roots of unity which exist but they are not real numbers? Yes, of course they are, and today we are going to discuss that. Okay, so let z cube is equal to 1. So from this we get z cube minus 1 should be equal to 0. This must be an equation for this. So now this is a cube minus b cube. We know the formula of a cube minus b cube. A minus b into a square plus ab plus b square is equal to 0. Now we know how to solve this. We can write this z minus 1 is equal to 0, or z square plus z plus 1 is equal to 0. Now the solution of z minus 1 is equal to 0 is z is equal to 1. So one of the cube root of unity is z is equal to 1, and this is a real number which we have already discussed and we know it from our class 8. Okay, now this solving this we get two complex numbers which are the cube roots of unity. Okay, and that's important for us. So z square plus z plus 1 is equal to 0. This is a quadratic equation and we know how to solve a quadratic equation. So z is equal to minus b, b means the coefficient of z, so minus b plus minus root under b square means 1 square minus 4 into a means the coefficient of z square, that is 1. So 4 into a into c, that is 4, divided by 2. We get minus 1 plus minus root under minus 3 divided by 2. Now here we get a complex number, and this complex number which we have got, this imaginary number, we can write this root under minus 3 as root under 3 into I. So we can write z is equal to 1, or z is equal to minus 1 plus minus root under 3 and here I divided by 2. So we have three cube roots of unity. Z is equal to 1, z is equal to minus 1 plus minus I root 3 by 2. Okay, so here two cube roots of unity are included, plus and minus. If we put the plus value, then we get one cube root of unity, and if we take the minus value, then there will be another cube root of unity. So the cube roots of unity are what? 1, okay, minus 1 plus root 3 here I divided by 2, and minus 1 minus I root 3 by 2. Okay, so we have three cube roots of unity. Now the 1 is 1. Okay, so 1 here, minus 1 plus root under plus I root 3 by 2 is denoted by a special symbol. Okay, minus 1 plus I root 3 by 2 is denoted by a special symbol omega, and minus 1 minus I root 3 by 2, which is the third cube root of unity, it is denoted by omega square. Okay, so we have three cube roots of unity. Now we will discuss some of the properties of the cube roots of unity. Okay, so let me erase this. So up to now we have find out the three cube roots of unity. Okay, so now we are going to deal with properties. So the first property is 1 plus omega to the power r plus omega to the power 2r is equal to. So we have two values for this. Okay, the first value is 0, means 1 plus omega to the power 2r will give 0 when if r is not a multiple of 3. Okay, and it has two values, and the second value is 3, and when does it give? If r is a multiple of 3. Okay, so let's take, if we write 1 plus omega square, which are the cube roots of unity, then what should be its value? So here omega to the power is 1. Okay, so 1 is a multiple of 3. No, it is not a multiple of 3. So the situation comes this first case. If r is not a multiple of 3, then what will be its value? Its value will be 0. So 1 plus omega square will be equal to 0. Okay. Now omega and omega square are the cube roots of unity. Okay. So when we will do the cube of this, okay, like omega cube, then our answer will be 1. Okay. So these are the properties. Now I think a question is necessary to understand it. Okay. So let's find some questions.